Okay, I think we'll get started, even though there's still a murmur out there, but we'll just start with some logistics and everything and get going. So thank you for all coming. This is the session about citizen science, as well as some of the resources that are available for outreach that, great to share with everybody. As just a reminder, I think we've all seen these slides a couple times today. I don't know how everyone's social batteries are doing. Hopefully okay. It is still Monday, but hopefully we're going to make it through. And a reminder to stay muted on Zoom. We have our Slack channel, which is the citizen science one there. So feel free to join that and ask questions, as well as on Zoom. So for this session, we're going to kind of do two parts. The first part will be quite citizen science focused. I'm going to give a little introduction to what citizen science with Rubin is, and then we will have Colin talking about our first Rubin citizen science projects, Rubin Comet Catchers, as well as Chris talking about Galaxy Zoo and beyond. We'll have time, there's plenty of time for some Q&A and discussion if we need, and then we'll talk about some other resources that are available, might be of interest if you are a fan of outreach. Okay, so I will get started just giving a little bit of an overview of citizen science with Rubin in general. So for introduction, my name is Claire Higgs. I am the astronomer on Rubin's education and public outreach team. So this is citizen science is one of the things that the EPO team is working to support. But the Rubin Citizen Science team is actually a collaboration. So there's folks like myself on the Education and Public Outreach team, as well as folks in the Community Science team, CST team, some of whom are online. So definitely feel free to ask questions there as well. And in collaboration with the Zooniverse, which is, I'm sure you all know, but a well-known citizen science platform. So big picture overview, citizen science with Rubin. What we're trying to do is create tools and a community for Rubin Observatory. So our little team is small, and we are hoping to work to create ways for members of our community to do science. We are not running. Can folks on Zoom still hear, or?
We can hear you, but the slide didn't advance.
Okay, we've got a spiral here. I'm glad you can still hear. Am I just?
It's all right. I just pinned your window and I can read the slide off the wall.
Yeah, let's. I don't know if this computer just. Nah, hang on. No. Now it's all frozen. This I think Zoom just crashed on here, and now I can't get out of screen share. Oh no. Oh, there we go. Okay, now I'm out of here.
Yeah, first things check to see if people can hear you on Zoom.
People on Zoom can hear, but Zoom just I think just ended on this computer that we're sharing from. Sorry, please talk amongst yourselves for 2 minutes. 1 minute.
Can you give us a topic?
What is your favorite thing in the first look images? What's your favorite pixel? You got a few million to choose from. I mean, well, I could just open it on Chris's.
If you already have it ready, yeah.
Can you go to the project agenda website and I'll just reshare my slides off your one? It's like, yeah, whatever the agenda page. Oh, perfect. Yes, and then just do that one. Wait, share and then yeah.
You want to share it first, huh?
Yeah.
No, not share the screen. Share the.
Share the screen.
And then if I just do,
Ah, very nice.
yeah, and
Really?
then slideshow that, and then perfect. Okay, great. And then we just have to fix that before we get to Colin's talk. That's fine. We got lots
Oh,
of
no,
time.
but we're still,
Oh, what's going on? Oh goodness.
oh, yeah, that makes
Okay,
So people here can see and people remotely see.
We can see now.
beautiful. Okay, sorry about that. And let's go. Okay. Oh, we can use we can fix it there. Okay, we're good. We're good. Thank you. Okay, sorry about that. Picking up my train of thought again. So yeah, our citizen science group is working to help you as members of our community make projects. Our team is not directly running projects. Oh, and sorry, I'll just minimize this as well. Okay, and why we were doing this? Well, the whole idea is to support our science community into making projects, making it a little bit easier, more streamlined, and also from the education and public outreach perspective, trying to leverage our mission and our priorities to welcome more people into participating in Rubin Science and being part of the exciting discoveries to come. And this is really comes out of the data volumes challenge of Rubin. It's the problem, but the good problem to have of so much data, and the fact that we want to reduce some of the challenges of working in data sets the size for our science community. And we also want to maintain public interest, momentum, investment, engagement throughout this, really long survey that we will have. And there's, plenty for everyone to do, including our volunteers, citizen science. Now I can't switch slides. There we go. Okay, so how are we doing this? Our goal is to facilitate this easy and straightforward project development for our science community and to nurture this community of dedicated volunteers for the public. And so we're doing that in partnership with the Zooniverse. And to tackle this first goal, we have templates, documentation, and support that exists. Really the backbone of what we have is a pipeline to programmatically send and retrieve data from the Rubin Science Platform, the RSP, to a Zooniverse project, so it can be shown to your volunteers, and then retrieve that data back to the RSP, allowing scientists to use everything that's available on the RSP to do your analysis, as well as that connection to the Zooniverse. And we make this available using tutorial notes. So just breaking this down a little bit further, some of this documentation and support is available at citizen-science.lssc.io. There's more coming soon. I will say we currently have a bug, so there's some things that haven't shown up today as intended, but there's more coming. But some of the things I want to highlight there are we have a data policy. So citizen science falls under the same data policy that Rubin has for all our images, but understanding how to do citizen science within that framework is a little bit complicated. And so we have kind of an explainer there to help navigate that. As well, we have an existing project catalog. Of course, there's going to be a huge amount of data, and we do want to reduce projects that perhaps duplicate effort. And so one of the ways we're trying to do that is just making folks in our community aware of what projects are underway, have happened, and make connections and collaborations where it makes sense. So I mentioned the software and tutorial notebooks that exists. So we have this Rubin CitSci software package, which allows you to send and retrieve data from the RSP to the Zooniverse. Importantly, we also provide storage for your data in the Education Data Center, so the EDC, to allow that transfer. And all of these notebooks that we have are described in the documentation. If you wanted to use them, you are currently limited to only sending 100 objects. That limitation is simply just to make sure that folks don't accidentally send a huge amount of data without realizing what's going on yet. But we can easily change that limit whenever anyone needs to send more than 100 objects, because that's not a very big citizen science project. So the notebooks we have include just a basic example of sending PNG images, a flip book, which allows you to send multiple images of the same object and shows you how to do an example of how to aggregate classifications on the universe. That are classifications from this universe as well. And we have more coming soon. I will say if there is a citizen science project that you've got kind of in mind, thinking about how you might do this, we'd love to chat and discuss how we can make some of these tools work the best for your project. We, in collaboration with our CST friends, there's some notebook tutorials and supports for using AI for citizen science. And so there's a general introduction to using AI classifications in PyTorch that's available, and with more under development, including star galaxy classification, anomaly detection. And there's more machine learning features that I think Chris will talk about later in the session as well. And so that is as well as included in our documentation. Some of the other ways we're trying to make it easier is create a template so that if you want to start a citizen science project, you don't have to start with a blank page. And we have a template that has some general Rubin information and some education materials and things like that. This is not something you have to use, but hopefully makes it a little bit easier to start a project. So that's kind of our first goal, hopefully how we're trying to achieve that. And then our second goal of trying to create a dedicated community of volunteers and highlight amazing science. We do that in a couple of ways, but one is trying to respect the time and effort that volunteers put in, so minimizing the overlap between projects as much as we can. And it is known that the motivation of volunteers wanting to participate in citizen science is seeing that they're contributing to scientific research. So as the EPO, one of the things we really try and do is highlight science to the public. And so we want to make sure we highlight contributions from volunteers back to the public as best as we can. We have a Rubin organization page, which I'll show in a second. And we also want to connect to everything else that EPO is doing in ways that make sense. So this community page is a place where all projects using all citizen science projects using the Rubin data can be collected together and hopefully create this community of volunteers. We proudly have one project, our first project there, but hopefully there'll be many more to come, and Colin will tell us more about Comet Catchers in a minute. And this allows us to collectively promote all projects using other parts of our EPO, including social media and on our website. So mentioning the other ways we can connect. So again, social media through our website, but also one of the things I'm really excited about is connecting to our formal education program. This is bringing Rubin data into the classroom. And so by connecting citizen science projects to this program allows us to bring active research into the classroom, but also bring interested classrooms to citizen science and have many more volunteers. So that's just kind of an overview of some of the things that we're thinking of and trying to support as the Rubin citizen science team. And I'm going to leave it here, but I'm going to pass the mic across to Colin to tell us about the first project that we have using some of these tools and where we might go from here. Oh, wait. And give us 1 second because we're going to have to re-up. Sorry. Just if you go back to the same webpage.
It was earlier.
We good?
Yeah,
Good.
great.
Okay.
We're good? Okay, everybody can hear me here and online. Somehow we know they can hear us.
Yep.
Awesome, thank you. All right, well, hello, I'm Colin Ryan Chandler. I am a postdoc at University of Washington DRAC Institute, where I'm serving as a project scientist for the LINC Frameworks Initiative. That's the LSST Interdisciplinary Network for Collaboration and Computing. That is the hardest part of my talk, is saying who I work for. And I'll talk to you about Rubin comment catchers today. So this is the first citizen science project live with Rubin data.
Colin, we are seeing the presentation version, not the full screen version.
Thank you, Wes.
But
At least I think that's Wes. All right, that's
No, I think I know, I can do it.
don't read into this too much, you know. I mean, I don't need the presenter view if you want to just do the slideshow, it's fine.
That's exactly the same as it was.
Yay.
very good.
That's pretty good.
Awesome. All right, Crispin on the rescue. Thank you. Awesome. Okay, well, let's get into it. Yay, it's working. Okay, cool. So quick, I'm a scientist, and so just crash course motivation as to why we're doing this. Some of you have heard this before, but comets can teach us a bunch of different things with tails. So we like ices and understanding things like where the water on Earth came from. So we know we have a clue that some of it was delivered after the fact, some of it came with the place. Asteroids have some, and now it's thought that that's where a bunch of it came from. But to understand these basics, we want to know where the volatiles are in the solar system. They also have practical applications like future space exploration, et cetera. Also, if we think that life is important, or if we think that life needs water, at least as we know it, then we want to know what are the conditions that bring water and where can we find it. So that's sublimation, but there's other reasons to study active asteroids and comets and other things that have tails, and that's for other astrophysical processes. So these can include things like impact events, and that has planetary defense implications, like the DART mission, where we hit something to see if we could deflect it. Comets also hit Earth, so they are also nice to understand from that perspective. There are other mechanisms too, like things can spin too fast, they start to fly apart. There's thermal fracture. There's one object that gives us the Gemini meteor streams that undergoes this process. We can arrive at an asteroid for a mission to see pebbles flying off everywhere, like as with Bennu. So understanding this have a bunch of different implications. So that's why I find them very interesting, and that's why a lot of people find them interesting. That's cool. I'm only seeing half my screen. As long as everybody can see it, that's good. So the thing about these objects is that they're very rare. Like, so this is a classic needle in a haystack problem. There are only a few thousand comets known, and I always like to rub it in that they were known as minor planets for many thousands of years before we found an asteroid, but there's only a few thousand of them known. And there are even fewer of these other active body populations like active asteroids. These are asteroids with tails. There are other populations too, like the centaurs that orbit between Jupiter and Neptune, of which only like 20 are known. So we're talking, in the order of hundreds, as opposed to the 1.4 million known asteroids, soon to become 5 million with Rubin's finds. And so they're rare, and they're rare for a bunch of different reasons, but we just would like to find more of them. And so how would you go about doing that? This is the first active asteroid ever discovered. I just love the fact that it was actually imaged on a plate. So there is an image of the first active asteroid from 1949. And that just makes me really happy as an archival person. So where do we look? Okay, we've seen this image before, but I just like to remind that there's reasons why Rubin is especially good for this kind of project. That is, it has a really wide field of view. So we've got the full moon in there. And that's a lot of area on the sky to capture a bunch of images. To capture a bunch of objects to look at. It's a large telescope. I've realized I need to stop putting a diameter because people get snippy with me about it. But it's a great site in Chile as well. It has really good conditions, and it's a well-calibrated telescope, which is important for a bunch of reasons. I'm also on the commissioning team, so I'm a little bit biased, full disclosure. And this facilitated access. So the recurring theme around here is going to be the Rubin Science platform. And so it does make life easier when you have one place where you can get at everything that you need, the pixels, the table data, all that good stuff. And it's in commissioning now. The data preview 1 data set we're hearing a lot about, that's already live and up there and available for data rights holders to get access to. So that's about the rough size there. So maybe call it a full moon. And that's like 1/22 or so of the rafts that are there, but it's still a very respectable data set. It's got a really well calibrated data set too. So it's kind of a bespoke catalog and image data set to work with. And it's available now. That's very important. I have a little sprinkle in here, and I just was scaring Bob earlier, so sorry about that. But I did put some LSSDCAM images in the public project today because there are some with this paper that's coming out. So we want to see how that works, and we'll talk about that in a second. I really don't like embedding videos because now there's a pinwheel because it was too big. You see, we weren't allowed to upload large files. So we'll see if this actually works, or if we get like strange ads for car insurance or something. Yeah, no, I don't think it's gonna work. That's okay. We've all seen this animation many times, probably today, actually. The takeaway here, though, is that there's a lot of dots to look at. Every one of these things, and all the ones that were in the animation that we're all familiar with, are all new discoveries on top of that. So there's a huge stream of discoveries that are coming. We have a bunch of simulations that have studied this, so we're talking about 500,000 observations per night, and that's a lot, including new objects. So this brings us to citizen science. I think if you're in this room, you probably already know that there's a lot of great things about citizen science, education, outreach, opportunity. For me, that's first and foremost. We are engaging the public in a quest, a scientific quest, and I really love that about citizen science. There's a lot of really amazing people and enthusiastic people. It's great for these overwhelming data sets. I mean, that's what we've got going on here. And this is my second citizen science project. We're going to see the previous one is our sort of proof of concept as well for this. But we are just like, for overwhelming scale, again, we're getting to the point where we're going to have in 3 months, like all of the DECCAM data, all the data ever used for my other project will be taken every 3 months with Rubin. So it's a completely different scale. And so we need to do something about that. And that can be maybe with AI or some combination of features, which citizen science is also very helpful with. And related, less examination bias, which is amazing. I have to admit that there are volunteers that are not professional scientists that are better at spotting comments than I am. And I have looked at literally millions of images. And so it takes away my bias from the whole process too, which is important. So I was mentioning this, that I have this other project that's active asteroids, and I found it in 2021, and it's sort of our proof of concept here. This was actually made with Rubin in mind at the time. And so we have a bunch of discoveries from that project, and that's awesome. So this is the same general concept. And the main point is to show that we have these discoveries. So we know this general platform can work, and it's a sister project as well. So we have sort of a volunteer base that we can invite on board, especially in this sort of early preliminary data set. How does this whole thing work? Just is way oversimplified, but it's a field of view. We figure out what's in this field of view. There's different services that do it. In the past, we would use Skybot or maybe the JPL object and field. But now we have some stuff at Rubin that we would use directly to say which asteroids and comets might be in the field of view for each image. And from there, we pull out the chips and we make sure it's actually on a chip, because that's the thing. And then we reorient it so that they all have the same orientation, because for those that don't know, Rubin is not always rotated the same way. And so you're not aligned with the sky celestial coordinate grid, which I got very spoiled with DECCAM, for example. So we reproject those so that they are commonly aligned. And then we do the CSI enhance to the right frame. And this one actually does have a tail. It's going to, ooh, that doesn't show up at all there. Never mind, there's no tail. You can't see it. So yeah, and this is what the actual mechanics of it looks like. This is the Rubin Science platform, which it's a platform that can be installed in different data facilities. This is the one at USDF and Stanford. But the principles are exactly the same. So you put in your repo and you do your stuff. And this thing is like, oh, I'm going to go and cut out 33,000 thumbnails from these things, and it just goes and does it. And that's awesome. So definitely it's not just a toy, it's really worth using and it's extremely convenient. So I have done all of the work for creating this project on the Rubin Science platform, and it's great. And some of those tech details, because everybody likes to know, just yes, all done on there. And this is with ComCam, it's effectively 10,000 cutouts of asteroids that are in ComCam. This is a very small number compared to 500,000 that we're getting per night right now with LSSD cam, but it's still a very good set. This is the size is about a megabyte per. So if you take that for 500,000, you can think, wow, that's a lot. And also it takes 5 seconds to do a cutout. And so 500,000, that's a lot of seconds every night. And yeah, there's parallelization, all that good stuff, but still. And so we're using a flipbook this time, which we heard about that earlier from Claire, and we're all about it as a new method. So the scientists sometimes are a little opposed to this because it's a little bit more complicated to disentangle which of these images shows activity. But everybody, especially all my undergrads and all the other students, they're like, no, this is the way we've got to do it. So I'm kind of excited about it. We're doing these permutations of the flipbook. So like if we have 3 images, we show image 1 and 2, and 2 and 3, and 1, 2, and 3. And we can do this experimentation right now because we have this sort of finite data set. And we'll talk about that again in a second. We are training, like we have images of known comets with tails. Those are from the dark energy camera data that I've already derived from before. Because hopefully we're going to find some comets in ComCam data, but there weren't any that were directly images on purpose anyway. So this is what it looks like. If you go to the project, it's this simple. Just you're shown a thing, it's animated, and you say, do you see a tail or not? There's no tail on this one. Either way, there's no tail. And there's this little reticle, and you do have a field guide the whole time, and there's a tutorial, and so it's like your normal citizen science project, and you can take it directly to talk. This is like a chat forum. I think this is downplayed a lot when I talk to people about it, but it is a pretty important path for discovery, including for us. For my previous project, it was the first discovery we made was like on the day it launched was through talk. And so that's actually that image right there. But the normal route would be people classify stuff. It goes into these records and you analyze that data in some fancy way. We get these candidates, which we look at the science team, and then we do follow-up, which is an archival investigation because I love archives. And with Rubin, what's different is the archive will probably often be ourselves because there's going to be a pile of data already. And then telescope follow-up, which we do the whole campaign that we've got at many facilities. So I can't help myself but talk about Interstellar Comet 3I. This is when the adaptive optics is totally working, by the way. That's exactly what Rubin saw right there, because that is the theme. The goal, the reason why I'm showing this is because this is exactly the kind of activity that volunteers are good at spotting and finding. This data was not available to them at the time because of the timing of when it inconveniently decided to arrive in our solar system. Those are actual LSAC cam images over there from the paper. And so we did sprinkle these in already into the project to see how folks do at finding it. And one of the reasons why this is important for me is that the goal for me has always been for the Rubin comet catchers to have a more frequent sprinkling of data to sort of keep things exciting and more recent. Okay, just a little bit on AI. So we have this super primitive AI that's called TailNet. It's like a prototype. And I just like to downplay it because it is really rudimentary. It's trained on almost all no answers too, right? It's a needle in a haystack. Everyone's saying no all the time. So it's really good at no. It tells you no. Very happy to do that. There are very rarely times when it says this is definitely not garbage because it only knows garbage. And so when it's super not garbage, we look at those and it's made 5 discoveries that way. So it's definitely the first AI that's found active asteroids, maybe about comets and some other stuff, which is really cool. And the goal is to, this is an assistant to the volunteers. So it is to filter out the trash, basically, to make it so that the experience is better. And I could inject this at any point, but by the way, you cannot actually have discovered a comet without human eyes looking at it. That's just the way the IAU platform works. You got to see the thing on 2 images and 2 nights and this whole thing. So it does need humans to look at them. So even if we wanted that thing to actually do it, it can't. But it can help us to get better at filtering through stuff. Yeah, okay, so the other thing is we like to talk about unknown unknowns a lot around here. And one of the things that happened with Active Asteroids Citizen Science Project is that we made a bunch of okay, that's what we set out to do, is to find these really hard to find things. And that's great, we found them. What we were not expecting were these other discoveries. So these are discoveries about known comets. And the very first publication we had actually was about a known comet 282P, and it turned out to be a really odd duck. And like you can see here, it's off center from the middle, and it sort of led to a whole investigation. And things that volunteers identified that maybe I would have just really looked past because, oh, it's already a known comet, moving on. And that led to our first publication. It turns out to be an active quasi-Hilda, which is an odd, like almost interior 3-2 mean motion resonance with Jupiter object. And it's a lot of fun. So I really can't wait for Ruben to see what kind of unknowns are in there. I have a quick lessons learned page. So if anybody's here thinking about doing citizen science stuff, since I've just been going through it and tried through it, and I was really determined to be the first project to use Ruben, like a little bit to a fault. But I had been preparing for it for like 8 years or something. So starting early and being patient, both those are really good. So like I said, 5 seconds cut out. Some of those things are slow. I do not sit there and watch it, like watch pot, slow to boil, all that stuff. Totally true. But also involving these folks early is really important. Like this is what Claire do. It's what the Ruben team is doing. And then Zooniverse has this whole crew. For the first project I did, I waited years, like where things were really well dialed in before I contacted them. And it worked out fine, but in this case, that would have been absolutely disastrous. And they just have a lot of stuff already in place to help. So I cannot say that enough. If you are working with NASA, and we are NASA grantees, they like to also have a lot of head notice for stuff. And so with data rights, I couldn't do that for launching this project. But just be aware, if you have folks that like lead notice and then you're not allowed to tell anyone anything until 2 days before, you should plan for that. Getting feedback from friends and stuff. This should be obvious, but you know what? It really helps a lot, especially things like the reticle. Oh my gosh, that's very important to say where the center of the image is for us. And we had like a month of polls and how long should they be and the color and the shade, and it was a lot. But I recommend doing that early. Welcoming translators. I know both of you heard me talk about this recently. We did not have this at all when the first product we had launched, but this product is now available in Chinese and Russian, Japanese, Turkish, a bunch of languages. And that's very exciting. It's kind of bringing in a new set of folks and making it much more accessible. And I'm very excited about that. And if you have limited data, which we do with DP1, it's great, but it's tiny, the small data set compared to what's coming. That is a really great time to actually test out stuff and try different things that you would never be able to. If we had live LSSD, I could not possibly test these different combinations of flipbooks and things like that. Like there would be no time to do that. I'd only be able to skim the best, discoveries off the top. So now I get an actual chance to do like a nice study of, do people really need to see 5 images in a flipbook, or can it be 3, or is 3 like definitely going to be false positives all the time? So it's got to be 4. So I'm excited by that. And then high retirement limit. This was a Chris suggestion and several others. And so we've telling volunteers like they're not going to be done anytime soon, because we want the whole world to come and try this. Because if we had launched this in the social media and then everybody arrives and there's nothing to do because it says project's done because everything's been classified, that's not the recipe for success in this case. It's much more fun for people to be able to come to try things. And so, yeah, we've had overall good feedback about that. Okay, special thanks to the launch team, especially my undergrad students that really helped drive this home. That was really, really awesome. And of course, Claire and Chris and everybody, including people on parental leave, like Cliff, and I appreciate it, Laura. So with that, again, it's live, cometcatchers.net will take you right there to the Zooniverse page. Thank you very much. Data under even with our joy.
Thank you. I think we have a time for for a question or two, if there are any in the room, or is there any online? It's quiet.
Hey, thanks, Colin. Not a question so much, but maybe you could comment on some of the interactions you've had with the volunteers on the Zooniverse platform, if there have been any. I haven't looked, but
Yeah,
and how
we
that's
definitely have been
gone,
interacting. Very early, yeah. I should have said too that there are different kinds of folks on Zooniverse that have different jams, and we do have some folks that they just like to be moderators on the forums and sort of facilitate answering questions for new people. Like that's just what they like to do. And these folks tend to find us early, and it's really, really great and important to talk to them. They're like angels, really, because there's just a lot going on. I mean, can be many thousands of posts right away. And then same with the translators. But no, folks are excited about different things and sharing and discussing different objects and what's going on here. We really put everything in from DP1. I didn't have a big menu to choose. Like I couldn't be specific because it's limited set. So put everything in. And so that does mean there's like image artifacts and other stuff too. So it's been interesting, people commenting on different features and we're learning a lot in the process as well. That's a good question.
There's a Zoom question from Neil that says, what do you mean by retirement count? Can you explain?
Oh
what
yeah,
retirement count
thanks.
means?
Sorry. And then also I like to talk about early retirement a lot because of this like early retirement system they have. So retirement is when an object is considered to be classified. So nominally, when we would first set up the project like my previous one, it would be 15 people look at an image before it's considered to be fully classified. And for us, it's just a yes or no. We did a study later that 15 was a pretty validated number. It was Zooniverse's suggestion, and they've got a lot of experience to back it up. We studied, and yes, it's got to be 15. You can maybe get away with 14, but there is a special case where if 10 people say yes or 10 people say no, we can retire it early. So that's what the retirement count is talking about. It's set at 250 right now, so everyone can try.
Perfect. Awesome. Okay. Thanks so much, Colin. And we'll switch over to Chris with some Zooniverse stuff.
Thanks. Thanks, Colin. Let's see if we can make this work. Thank you all for being here. Thank you for coming. Do I want to save new slide timings, Colin? No, I don't think I do. Good. Big. All right. Everyone needs to know Colin was under time. I will try and be under time too. Good. It's a pleasure to be here, not least because I have been coming to these meetings and talking about citizen science for 15 years at this point, and to follow somebody who's actually run a citizen science project with Rubin data is really special and exciting. And yeah, I think proves the value of this, that both from a science point of view, but also for the volunteers who we know from Zooniverse are incredibly, incredibly excited to get their hands on Rubin data. We've been telling them about this project for a very long time. And so there's amongst the 2 million people or so who are signed up to the Zooniverse platform, there is excitement about getting to participate in our science and to use images as they come from this marvelous observatory. So it's a really exciting time to be doing this. I'm going to talk mostly, though I wear many hats, I work with the EPO team as part of the LSST UK contribution. I was PI of Zooniverse for many years. I'm going to talk mostly from a Galaxy Zoo perspective, because I think it's a useful way to talk about what we've got done and what we still haven't got done. And the first thing I want to say really is that even without much prompting, citizen science is already happening, at least for advanced volunteers, using some of the images that were out during first look. So this is a recently published research note from a citizen science from Alexander Jonkeran, working with Bill Keel from the Galaxy Zoo team. And Alex spent a lot of time looking through the first look images to find things that they were interested in, which are these ionized emission line regions around galaxies that might be light echoes, that might be areas which have been excited by activity from the black holes. These are sometimes known as Voorwerpen, after Hannes Voorwerp, which is the first of these that was found by an early Galaxy Zoo volunteer. And there are 5 possible candidates here. But this is a volunteer, somebody who had done enough citizen science to set their own research agenda, making use of our data for their own things and then publishing in a professional format. So whether we would like this to happen or not, citizen science is going to happen. As we make data sets public or near public, then there are people out there who want to look through them. And I think that's important to bear in mind. But for most of our volunteers, it will be the formal projects, the scaffolded projects, that guide them into citizen science. That's important because it keeps people, it enables people to take part without much of a background, but it also provides the pathway that produces the advanced citizen scientists who can then do their own research. A lot of them came in through doing simple things. Now, I was hoping that at this meeting I'd be able to present the Galaxy Zoo Rubin project, but we're not there yet for reasons that we'll come back to. But I think if you just ignore the fact that everything I'm about to say for the next 5 minutes is about Euclid, this will work fine. You just have to imagine it's maybe September, and I can give the same talk with Rubin subbed in. So with Euclid, with the quick look data, we had the experience of spending many years telling the Euclid team that we should do citizen science and being told that their machine learning would be fine, only a few months before the data release to be told that they needed labeled data and help. So we helped. So we created a project using the Zooniverse project builder, which asked about the morphology of galaxies. Like Colin, we used a flip book. In this case, we showed a standard process, a grayscale image as well, and then a third image, which was designed to bring out the low surface brightness features in these images. We think with the Rubin pipeline, we don't need to do that. We think that the standard pipeline does a good enough job of both the fine features at the center of the galaxy and the LSB, the low surface stuff, that we think will be okay. But for Euclid, we did 3 images, and it worked really well. So in very short order, we ran this project for a few weeks. We got nearly 10,000 volunteers who looked at 114,000 galaxies and provided about 3 million separate annotations of those galaxies. So that's what we had about 10 to 15 people look at each one. And then having got those classifications, what we were able to do is scale to the rest of the data set by adapting a machine. So we knew from previous work that once you train a model to do a particular astronomical task, it can be retrained for a new data set. So these are results from Mike Walmsley, who's now in Toronto, and his work. So he trained what we call ZooBot, which is a deep learning system trained on pretty much every Galaxy Zoo classification that we'd obtained in the last 15 years. It's about more than 10 million annotations. Sorry, annotations of more than 10 million images. And then what this shows is this is how long it took to retrain a network to classify a new type of galaxy that hadn't been seen before. And in blue and teal are various iterations of this ZooBot, this Galaxy Zoo trained robot. And the red and purple and gray are large networks that have been trained for general purposes. Things like ImageNet, which was trained on basically everything on the web. What you can see is that the Galaxy Zoo network does a much better job. It learns much faster how to do this compared to these general networks, even though they're much larger and trained on much larger data sets. So there's something about scientific tasks, and you can guess what, it's that our images are different from a generic section on the web. That means you need a specialized tool. So we took our ZooBot and we took the Euclid data, and then rather than retraining the machine learning completely from scratch, we just learn a mapping from the features that that network's using to classify galaxies to the Euclid morphology. So if you're a machine learning person, we replaced the head and left the base alone. But basically, we're translating from its previous classifications into this Euclid space. And this worked really well. So we can now sort the hundreds of thousands of galaxies, might even be millions in the Euclid data release, into categories. So we've got 2-arm spirals, my own particular interest, which is bulgeless galaxies. So these are galaxies whose morphology suggests they haven't had a merger, and therefore they can tell us about how things like their black holes grow in the absence of mergers. We're able to find clusters of artifacts. So these are all common. This is a common type of artifact in the data, which we're able to find and then remove. And then we can do interesting things, I think. So these are galaxies which the model classifies as featured, which is a Galaxy Zoo word meaning not smooth, but not spiral. And it turns out that that combination gives you clumpy galaxies and a few multi-mergers. So it's an interesting point in the parameter space that we hadn't previously identified as interesting. So we can play around with this data. So this worked really well. And for a relatively small investment of about 10,000 people's time over the course of a few weeks, we could then adapt our model to work through the whole data set. So you should pretend that it's September and we've done this for all of DP1 with the galaxies. The reason we didn't was that we were expecting to get color cutouts as part of the data release, and that didn't happen. I think it was a there was a communications failure somewhere in the complexity of producing this. And the EPO team are helping us out. They're going to make those cutouts for us. And that'll be great. And then we can run this project. But I think going forward, we need to make sure that we can produce the artifacts that we need for citizen science out of our data releases. Not so much to save teams like Galaxy Zoo the effort of producing cutouts themselves. We could take the data that we've got and produce our own color cutouts. But because for lots of objects, there are going to be multiple projects that want to share the same patch of sky. So for example, we're working closely with the Space Warps project, which is a long established project with Aprojita Verma, Phil Marshall, and lots of Rubin people involved, looking for strong gravitational lenses. And we're both very interested in using the same cutouts and the same solutions to how you combine different colors in different bands for the two projects. Because if you're looking for lenses, being able to filter on galaxy morphology makes sense. And obviously our robot can also do quite a good job of pre-filtering for lenses. So creating a community set of cutouts or a community set of rules for producing cutouts is really important. And the lack of that in DP1 means we're behind at least where I wanted to be. So I don't think it's anyone's fault, but it does illustrate that as we knew, and as we've said from the beginning, the data needs of citizen science projects are different from the data needs of professional astronomers. We need higher level products shared across projects. So the other thing I wanted to talk about was to point out that we've built and renovated and documented and stand ready to support much more complex uses of citizen science than you've seen so far. And in particular, so far, Colin talked a bit about his machine learning. I talked about how you take citizen science data and use it as a training set for a machine learning tool that then does the rest of the work. But actually, for a lot of the use cases, we're going to want to do active learning or human in the loop machine learning or centaur learning or whatever you want to call it, which is displayed in this schematic where there's data coming from the telescope on the left. You take some of it out, perhaps randomly or perhaps via a set of criteria that you define. You annotate it by passing it through Zooniverse. It gets labeled, and then you use that labeled data to train machine learning, which you then deploy, but then you take more data out and so on. And you can think of this as a process that either you run at the beginning. I think a nice way to think about this, for example, is at the start of the alert stream, when we're trying to do calibration of real and bogus things, then you can imagine there being a great need for human classification, which reduces over time as the machine learning improves. But you can also think about this as a system that runs throughout the life of the survey, because inevitably the data quality is going to change over time. And so you're going to keep needing to train your ML to some extent to be able to perform in a uniform way across the survey. So we're well set up to do this. We've built a whole system on the back end of Zooniverse that is what we think of as an active learning loop that does what I've just said, that combines this semi-supervised learning to train the model. So we take a set of labeled data to begin with. We assume there is a model to begin with, which can be terrible. We put it in the loop, and then the model is expected to identify which data needs labeling. So one way to think about that is if you have a machine learning tool which can predict the probability that whatever you're seeing belongs to a particular class. If you can do that, then you can take perhaps the ones where the model is least certain, or better, those where an ensemble of models are uncertain, or even better, where you have an ensemble of models and some of them are certain and some of them are not, or where they're certain and disagree. You can identify which things that you'd want to pass through the loop. We have a whole ecosystem of tools to do that. So this is all Zooniverse side tools. So from the classification, there's a thing called Caesar, which does data reduction and aggregation. So that says what the current consensus is on an image. We pass it to a thing called CADE, which can format the data, get it ready basically for machine learning. And then there's a thing called Bajor that runs your machine learning, which we're assuming we're hosting in the cloud, and then passes back to CADE, which then decides what should be seen next. The details of this aren't relevant right now, but what I really want to get across to you is that all of this machinery is set up and ready to go. And so if you have a lot of data and you have enough ML expertise in your group that you can build that initial model with some specifications for us, then we're ready to run that for you and to put it into the loop so that you can get through a large amount of data very, very quickly. And if you want to do that, please come and talk to us as soon as possible. I want to say a few things about where citizen science is going. And so far I've talked, and Colin talked as well, about classification, about labeling data, typically within a set of known classes. But actually, I think the real promise here for Rubin lies in anomaly detection. And the way I've been thinking about this for a while now is this diagram. So you can plot all data on a diagram which plots on the y-axis how unusual something is, an object, a solar system body, a particular image, a transient, and on the x-axis how interesting that is, let's say, to you. Obviously, it will be a personal axis. And then you can think about where everything sits. So in the bottom left here are normal systems. In the top left, things that are unusual but boring are artifacts, or one of Elon Musk's satellites, or something like that. Bottom right's kind of interesting but not unusual, I think, is beautiful images. Like that's your nice spiral galaxy, maybe, or I don't know, a particularly nice Type 1a supernova or something. And in the top right is what we're after, with Keynote animations deployed, right? And what's interesting, when you think about these two axes separately, it's now the case that machines can do unusual really well. There are lots of good ways to take trained deep networks and get them to spit out a list of the most unusual things, but it's very hard for them to understand which ones are interesting. And so I think one of the things we're going to end up using citizen science to do is to take unusual things in Rubin datasets and identify how interesting they are. So we started playing with this. We ran a project in Galaxy Zoo called Weird and Wonderful, where we took some of the more unusual galaxies from, I think this is DESI, this is Sloan. And then we just asked volunteers, please click on whichever of these seems interesting to you. We insisted these are volunteers who have done at least 30 galaxies on the normal Galaxy Zoo. And what was interesting is there was a wide degree of scatter, which one would expect. But broadly, what we found was interesting. If you just look in the top left here, the color is the anomaly score assigned by the volunteers. So the redder the point, the more interesting our volunteers found that galaxy. And the shape comes from an automatic analysis of features from the network. So this is a space in which, a three-dimensional space in which similar galaxies should cluster together. And what's interesting is the things the volunteers found interesting are clustered in this space, but it's also a place where automatic anomaly scores, which is what's shown in the other three boxes, don't correspond one-to-one with what's going on. So the volunteers are finding things that are unusual, but they're also identifying the subset of them that are interesting, which are not artifacts. If you look at the ones that the machines picked up and the volunteers didn't, they're mostly boring artifacts. So this is beginning to work. We can also think of going a bit further, and there's wonderful work by Michelle Lochner in South Africa, who's built a system called Astronomaly, which is a recommendation system. So it's designed for use by a single astronomer, where you get an image, you say how interested in it you are, and then it uses a set of features in the back end to try and give you similar galaxies. So this is the same as on Amazon. Of course, if you pick a randomly chosen book, as I've done here, then you can see you get your recommendations of what else you might want to read. So we can now do that for galaxies, and it works quite well. So this is a paper by Michelle's student. So going from right to left, confusingly, these are images that were shown and selected to be unusual, and then each column is the result of clicking on 5 interesting galaxies. So you can see with just 25 clicks, you go from basically artifacts to kind of interesting galaxies you might want to run a follow-up program on. And so one of the challenges I think we've got in citizen science is this tool's clearly very powerful, but it shifts us from a collective where we have 15 to 50 people doing the same thing, and then we can take an average of their input, versus lots of individual citizen scientists using tools like this to carry out their own research. And we have to design a system that means that they can do that without swamping us or Claire's EPO team, or breaking the promise that when people participate in citizen science, they're doing something that's useful. There are ways to do this. I'd be happy to discuss them, but I think it's going to be really interesting. I want to point out in particular that I think in the next year, the need for this is going to be strongest in the transient space, because as the alert stream turns on, we're going to have all sorts of things that we're not expected. So when ZTF started ramping up, sorry, ZTF, I forget to translate, sorry. It's photo Z as well, by the way. Yeah, so when ZTF turned on, they ran a set of projects specifically designed to try and investigate what was there, and there's a reference on the slide for people who are interested. They showed people not just difference imaging, but also some context and a light curve. And so I think this will be a really powerful thing to do in the next year. And the other analogy we've got to it is a project run by an ex-student of mine, Alex Anderson, who's now a breakthrough fellow in Oxford, who looked at the light curves of objects in the radio sky as seen by Meerkat, and looked at how people could classify what was there. And actually that sort of sparse light curve is kind of Rubenesque, and I think there's lots we can learn from projects that already exist. So to summarize this part of my talk, public data, as soon as we release data, we're going to get citizen science. Really, our task is to think about who can participate and what the barriers are. Structured projects are important, not just because they're useful. They produce training data. They can be used in these advanced patterns, but they also increase the diversity of participants by contributing to Rubin science something you can do in a few minutes with no astronomy background. I think that's really important. We have infrastructure for really quite advanced things, so please talk to us. We'd love to use it for your projects. And the big challenge for next year is the alert stream. Claire, have I got a few minutes left? Good, okay. I mostly want to just switch and talk about a separate project we're running in the UK, because I think it will be of broad interest to this group. And that is that we're going to build a service on top of several of the brokers to allow people to adopt a piece of the sky. And the idea here is inspired by pretty much every museum and zoo you've ever been to, which will now allow you, admittedly for a fee, and we're not charging, to adopt an animal. So we think this will help bring down to earth and connect people the unique nature of the Rubin survey, both the depth and the fact that we're looking at a changing sky, but also create a reason for people to care. If we can have people connecting to their bit of sky, then they will want to know more when something happens. And that can then lead to the EPO efforts, but also to citizen science from there. So the idea is we have funding from STFC in the UK to create a microsite, which will exist online. So you can log on and you'll get assigned your piece of sky. I have all sorts of ideas about how you'll get assigned your piece of sky, which one will be meaningful for you. One idea is that it would be if you were born in the Southern Hemisphere and you know what time you were born, we can give you the patch of sky that was directly above your head. If you're in the Northern Hemisphere, it can be the one that was directly below you. If you've got other ideas, I'd love to hear them. We email you after every data release with a new deep image of your patch of sky, but we'd also build on the brokers so you can log back in and get an alert when an asteroid crosses your path or a supernova goes off, and we can scale the patch of sky to control the likelihood of those things happening. So a few use cases. So you can imagine a classroom, we've got a funding bid in to develop this properly, but we engage with a school. They have an activity in which they simulate being Rubin project members. They end up picking a science case, they get their patch of sky, and then a few weeks later, they get a phone call or a Zoom call with a scientist to talk about what's happened in their patch of sky. And there's something very nice about the fact that they'll have the same information about that patch as will the person in the science team. I think that's really lovely. You can also imagine in an informal science learning, if somebody goes to a planetarium, this is something that they could pick up and take home with there. So perhaps a family activity. And you can also imagine amateur astronomers, several of whom have access to networks of robotic telescopes, can adopt a patch of sky and perhaps follow up the brighter transients. So this is really early. We've got development funded. We're going to go live early next year. schools program being developed, and I'd love to talk to anyone who has thoughts about how they might use this or things we should build now that would be of interest. Thank you very much.
Thanks, Chris. I think we do have time for questions. Is there some online or one in the
Hi, good afternoon. I just wanted to know if there's any projects that you recommend for undergrad students to start with now if they have no experience.
In terms of participating as citizen scientists?
Yes.
Or, yeah. My usual answer is the projects that have the best link to open data is a good for undergrad, because then they could do their own exploration beyond then. If you go to the Galaxy Zoo classroom page, which allows undergrads to classify, but also then they can do things like make their own color magnitude diagrams from Sloan or DESI, and then think more about the science. So that might be a good starting point. The other one that's very rich is our Planet Hunters project, which uses data from TESS. Has an awful lot going on because there's lots of follow-up of interesting stellar systems as well as planets. So both of those sets would they've been around a while, and there's lots of resources around those two.
Very nice. Thank
Thanks.
you.
Also, comet catchers.
Thank you.
I was being looked at.
Yeah, and also if you look on the I think it's RubenObservatory.org citizen science page, we tried to link a few projects that are existing on Zooniverse right now that have something that is a little bit Ruben-y. And so there's projects listed there like Space Warps, where there's Space Warps projects, and then there will be a Ruben version of that project at some point in the future. So another idea. Still good online? Perfect. Okay. Well, thanks again. And we're gonna switch. Oh wait, Chris, I'm gonna just switch again. We're gonna switch gears ever so slightly. And actually, your Adopt Patch Sky is a nice little segue of the fact that our EPO team works on many things. Of course, one of which is citizen science, but we have lots of stuff that we really wanted to highlight a couple things that might be of interest to people in our community to use in whatever way you see fit. And so, yeah, it's me. Yeah, that one.
Yeah.
Perfect.
Yeah, that seems to have worked.
Can we have an okay if things are looking fine online?
Looking good to me.
Thank you very much. And so for the last part of this session, we're going to have Stephanie and Artis just highlight some of the outreach and education resources. So hand it over to Stephanie.
Hi, everybody. As Claire said, that Adopt a Sky thing was a great segue to this. So I am Stephanie Jeppa. I am the astronomy content strategist on the Education Public Outreach team, and I'm going to give you a real quick crash course to a whole slew of things that our team has. This is intended to be, hey, this thing exists. We're not going to go into too much detail about any one thing, but if you have more questions about anything you see over the next 5 to 10 minutes, there are several of us on the EPO team in this room who can answer more questions if you're interested. So without further ado, let's go. So the Education and Public Outreach team for Rubin Observatory has been a part of the construction project of the observatory almost since conception. And so alongside the physical construction of the observatory, the Education and Public Outreach program was also being built. And so what has come of that is a mobile-friendly public-facing website that I'm sure you're all familiar with by this point, RubenObservatory.org. And a lot of the things I'm going to talk about you can get to in one way or another from that website. That includes our gallery of downloadable visuals and graphics at RubenObservatory.org/gallery. And there's all kinds of stuff you can download and use in your talks or for anything that you are doing in your science or outreach life. Also in that gallery and in a few other places that I'll touch on in a second, we have a series of animated videos about Rubin and its science. You can use those videos in their totality if you want, like as complete videos, or feel free to like snip pieces of them. If there's like a 3 or 5 second chunk that really communicates something that you want, feel free to use just that section in your talks. And we also have formal education classroom investigations that you'll hear more about from artists in a bit. We have a strong social media presence. That's me. If you see stuff from Ruben's social media accounts, hi, it's me. We also have a grab and go slide deck for outreach, interactive data visualizations, and a resource portal. I'm blazing through those because they each get their own slide. As I mentioned, we have a stocked multimedia gallery where you can download and use anything we have there. And all of the captions and everything you need for those are all in English and in Spanish. We have even more assets available in a separate construction archive gallery. And those are additional images and documentation of the construction of the observatory primarily that maybe don't have quite the same level of caption treatment that the stuff on the main gallery does. But those are still there for you to use if you would like. We have a resources portal, which looks very similar to the construction gallery, but there's more kind of like things for you to use and go out and use and do something with, as opposed to just like images for download. And finally, we also have public friendly videos on YouTube. A lot of these are the animated video series that I mentioned before, but there are also a whole bunch of other videos that we've kind of earmarked as potentially useful for general public. And so we have a whole playlist on our YouTube channel that is just those videos, because we currently only have one YouTube channel where it's a whole bunch of talk archive recordings as well as public friendly. So that playlist is your spot to go if you want public friendly videos. New this year, we have an introduction to Ruben slide deck. And these are intended to be slides that you can just grab and go and use and adapt however you want. They are prepackaged. They have speaker notes with talking points. And so you can download and use those, and you can find the link to those at ls.st/resources. And new as of, I think, last week or a couple weeks ago, these slides are now also in Spanish. So if you're doing talks, whether scientific or public outreach in Spanish, you can use these same slides for those as well. The next set of products that EPO has been working on and developing over the last several years are our interactive data exploration applications. And we have two of them at the moment. One is called SkyViewer, which you are probably very familiar with at this point. This is the primary way that we presented our big wide field first look imaging. We have a sister application that is intended for solar system visualization called Orbit Viewer. And both of these web applications have or will have very soon guided tour exploration modes as well as a free-form exploration mode. Orbit Viewer is coming soon with the guided tour that is in the next kind of month or so of development that's planned. So that will also be something that you can use in any sort of setting that you'd like. And finally, SkyViewer also includes a sonification, which I will talk about in more detail in just a second. So first, Orbit Viewer. Again, as I mentioned, this is our three-dimensional interactive data visualization of the solar system. And this uses real data that is pulled and synced with the Minor Planet Center. So it is up to date as the Minor Planet Center is. We also have a number of different customization options for the visualization that let you kind of look, display the solar system as you would like, including a filter that will highlight just Ruben discoveries, which is pretty cool, in my opinion. You can also get detail about specific objects by clicking on the ones that have a little label on them. And then you can also view the high-level context if you zoom out. The color coding is communicating the different classes of objects in our solar system. And so you can get that kind of high-level view. And finally, Orbit Viewer is intended to be responsive to your device and connectivity. And so we have 4 different options for the number of objects that you can visualize, depending on whether you are on a phone or a high-end laptop or anything in between. Next is Skyviewer. As I mentioned, this has a guided and a freeform explore unguided mode. And in the corner, I highly recommend the share option. This is really great if you find something that you really like and you want to share it with somebody. You can grab a link to exactly the view that you're looking at. You can also download an image of that exact view, which is really handy for sharing what you're looking at. You can also right-click to get the coordinates and a link to the coordinates of a particular object if you find something that you're interested in. And then the other fun part of Skyviewer is what we are calling SkySynth, which is our sonification of the images that are available in Skyviewer. So this is also interactive. We developed this to be kind of in line with the experience that you have browsing an image in Skyviewer, where you can kind of get lost and explore as long as you want and as in-depth as you want. We wanted to replicate that experience in the sonification as well. So there are two modes for the sonification. You can have a free form kind of random walk where it just kind of goes and plays and drifts on its own, or you can press the pause button up in the corner and do your own manual exploration and drag to specific places. You can also do that in an automatic mode as well. And if you want to learn more about the sonification, how we set it up and how it works, we have a web page on our website, ls.st/about-skysynth will take you there. I think this is my last slide, a fun activity that primarily our education team developed, but that is very useful, I think, for anybody, is we have a coloring book now, which is really fun, and I haven't downloaded it yet, and I really want to, because how fun is that? It's available in English and in Spanish, and there are, I believe, 6 different pages you can color, and each has a little sentence or two about the particular scene that you're coloring, as well as some basic information about Rubin Observatory. So highly, highly recommend that. And big kudos to, in particular, Artis and her education team who really spearheaded the effort for that. And with that, I will turn it over to Artis.
Quick question.
Or take
before
some
we
questions
hand it
first, I
over.
guess.
Do you wanna read that?
Yeah, I might be able to answer it too. There was a question online about whether there's a plan for adding EPO materials in different languages, or maybe an opportunity for volunteer translators. So the EPO team has bandwidth to provide materials, and we're focusing on our primary audiences in the US and Chile. So we have sort of committed to translating things to Spanish. However, there are a lot of products that we've got, and we have been working with people on individual ones to translate them into different languages. So if there is a product that you're particularly interested in for your audience, and you are, either volunteering or know of people who might volunteer to translate, I would say contact us, and we can sort of talk about the details. That work?
Okay. Perfect. Any last questions for staff? I'm gonna hand it over to Artis.
Thanks. I'm Artis Harold. I'm the educator on our EPO team, and I've been working for Rubin about 8 years now. I'm going to talk to you about a couple things that are not all necessarily education, this one being Sky Surveyors. How many of you have played this game before? Lots of fun. It takes 1 minute. So, I mean, it takes about a minute to learn it, and then it takes a minute to play it, and then another minute because you want to get a better score. But it's a great way to learn about what a survey telescope is. And as you're doing outreach, this is a really nice, quick engagement tool. So if you're starting to talk about Rubin Observatory and the legacy survey of space and time, and at that point, people are starting to go, what's a survey? Pull out your phone and play this game. Works really well. If you go to the main website, there is a bar on a tab on the menu bar called Education. And that's where we have all of our education resources that have been there for quite some time. However, for First Look, our team spent the good part of the last year developing some specific First Look resources for education. And I think in a way, many of you will find that these engagement pieces will work very well in public settings, giving general talks. So if you go to the education bar, you'll see immediately right under it this tab called First Look Resources for Lasting Impact. And this is our First Look for Education page. So one of the things we wanted to achieve with designing First Look resources is we wanted to develop a degree of engagement for students and teachers that went beyond just looking at a pretty picture and moving on. Because, you know, a lot of people get really excited about an image and they look at it a number of times, play with it, share it, maybe read the caption, hopefully. And then it's kind of like they're waiting for the next big thing with the next pretty picture. And we wanted them to engage a little bit more in the science and understand that the image is, you know, very little of what is going to be delivered with Rubin Observatory. And so we've designed this page with a lot of different tools on it. And I'm going to just briefly talk about a few of them. As Stephanie mentioned, the Skyviewer has guided tours that we can go on. And we developed 2 guided tours once we knew that we were looking at the Virgo cluster, focused on galaxies because there isn't much else there in the Virgo cluster. But one is called something like a gallery of galaxies, which is kind of the basic level of galaxy you'd encounter in an introductory astronomy course or textbook. And then we have exotic galaxies. So we broke them into 2 tours. And the way these work is they're actually not linked from the main Skyviewer page. They're linked only from the education page you can get to. And we take you through a bunch of different kinds of galaxies, give you some fun facts about them, and also some engagement questions. So we have a lot of did you knows, which are kind of like the fun facts, but then we have do you wonders with no answer, except in the teacher guide. So here's where the teacher or the educator or you as a public outreach person becomes the facilitator, where you can say something about the did you wonder questions. And so we give you material for that. The next thing I wanted to mention is that we have a First Look toolkit that's on this page. And something we realized early on is, as Stephanie alluded to, our website is very rich with resources. There are so many things there, but how do you find them quickly? So what we did is we developed a toolkit. So really quick, if you want 3 things about the telescope, 3 things about the mirror, 3 videos, we kind of laid out the most popular general tools there. And if you're giving talks, doing outreach, even if you're not in an education setting, I think that might be useful for you to explore. We also developed a Rubin Bingo game, which quickly became renamed Rubingo for obvious reasons. This has turned out to be extremely popular, actually, much more so than we thought it would be. And again, this is really a fun engagement tool. And if you would like to join us in an unconference session, we're going to be playing Rubingo. You can actually participate in some scientific research because we've developed 50 cards that are randomized so that they could be printed out for a class of up to 50 students, which is not uncommon in Chile. God bless the teachers there. But, and you'll hear a little bit more about Rubingo too at the First Look Show and Tell if you're coming to that session. But we could use your help in identifying if we have any duplicates that bingo on the same card, same time. So we're offering some prizes if you want to come to the unconference session and play Rubingo with us. That's available also in English and Spanish, as most resources on our website. I'm not going to mention this again. I think Stephanie did a great job, but we have a lot of short 2-minute or 30-second animated videos that are really great to drop in for talks. And finally, if you happen to have any educators in your audience, please encourage them to take a look at our interactive investigations. We have 7 of them right now. They are designed to intersect what Rubin does well with what students typically learn in an introductory astronomy course or unit. Everything is there free. We have assessments, we have phenomena, which are warm-up activities. We have a lot of other support materials for teachers, especially good for somebody who gets thrown into an astronomy class to teach for the first time, and they haven't had the experience of what students are going to ask and how you might answer those questions. So a lot of those resources are available there. So I encourage you, if you have any teachers in the audience or grad students who are going to be teaching an astronomy course for the first time, a great place to point them. And with that, I believe we're done.
Thanks, Artis. And there's questions.
So the question is, how can undergraduates, graduates, or willing scientists contribute to this educational resources aspect?
Talk to us or me. You can talk to me. In particular, I'm always willing to chat about particularly what kind of things you're interested in. As hopefully we've demonstrated the last little bit, we've got a lot of things going on. So yeah, I think we're always up for a chat and see where we might collaborate.
I'll just add to what Claire said. If it's specifically educational resources, as she mentioned, talk to us, because we've been working with educators since 2017 now, and we've developed what I feel are robust and well-working products based on the input of thousands of people around the world who have tried them out or told us what we were missing that we needed to add or do. So please do contact us.
Thank you. So I help lead a citizen science project called Killanova Catcher, and it's a pretty large team of very experienced professional, pro amateur astronomers with a range of 9 to 13-inch telescopes. And they really help facilitate the optical counterpart to gravitational wave searches. But they don't have necessarily the precise scientific photometry experience or how to understand Rubin data. So this may go to what Claire and Chris were talking about, Rubin science. Is there going to be any sort of integration between this type of information that's being put out and helping people understand Rubin data, and especially to even go beyond that, maybe like an alert system that could be integrated into, for all intent purposes, citizen science projects like us?
I think I'm going to partially answer your question, and maybe I'll let Chris, if everyone's add anything there too. But yeah, I think so. Our focus for our Rubin citizen science efforts currently is projects that kind of exist in the Zooniverse ecosystem. Part of the reason for doing that is one thing that Rubin has is a ton of data, and so getting that data to Zooniverse and having the public participate there has kind of been our primary focus. You're right in that there are many types of citizen science that happen that don't exist in that kind of paradigm that exists there. And what we're going to do with that is still slightly to be determined. And I think one of the reasons that we haven't, that I don't have a super specific answer is I think it's very project dependent. I think there is no one size fits all answer. And I think, again, not to sound like a broken record, but come talk to us, because it'd be very interesting to know kind of like the specificity of like what you're thinking that might look like to work with Rubin data. You got it.
Yeah, it's a great question, and as Claire says, it's a different set of needs than the data out projects we've been thinking about. The people I get you to talk to, and I can introduce you to some of the broker teams, I think, who've been thinking hard about how to get alerts out to all sorts of people. I know the Laser team, for example, it would be easy to build a custom filter for your participants so that they could be alerted to things they might want to follow up. But I can point you at those resources or connect you if needed. We'll talk.
Charles, do you want to go ahead and unmute?
Thank you. Yes, a couple of bigger picture questions. First of all, you have all done such tremendous work. Thank you so much. It really has been amazing to see how Rubin EPO has gone from construction to commissioning to now, operations. You guys are ahead of everybody else, of course. I have one question regarding the shape and size and budget of Rubin EPO right now, and just how much we can, as a community, lean on you guys. How much bandwidth do you have to actually help us do all our projects? If we have no information yet or no knowledge, can you help us from beginning to end, like all concepts all the way to execution and everything? Or is that asking too much? Or and how many such projects can you support? That's sort of one general question. Then the second general question I'll ask in a second, if you guys can answer this one or give us a sense of what we can think about.
Sorry, can I just clarify? Are you talking about specifically supporting citizen science projects or other ideas and projects in general?
Specifically citizen science, but generally all projects. I mean, how much can we push on you guys? You guys are already doing so much, and I know there's a lot on your shoulders on otherwise, like just the whole project, of course, is stretched thin. So can I tell my friends and colleagues, for example, and say, yeah, go talk to them, or will it like stress you out because there's just too much?
Okay. Well, I'll say, so thinking specifically of citizen science. So supporting citizen science is kind of one of the core parts of our EPO team. So we are excited to support them. I will say one of the big unknowns for us here is exactly how many projects are going to come out of our community and on what we do there. But I do think, just as I was mentioning before, every project is different and the level of support is different. So I don't really want to give like a very hard number of, put a value on it. But I think we are ready to really support the citizen science aspect. Chris, I feel like.
Yeah,
Okay.
just to say, if that was a question from Zoom, I wish you could have seen Claire's face as that very diplomatic answer was composed. But second, I think from a Zooniverse point of view, the system's built to support many, many, many projects. So if you're doing something that's off the shelf that we're expecting, you shouldn't need to talk much directly to the EPO team. It should be straightforward, and then we can support many projects. It's when people want to do bespoke things or more complicated things or more advanced things that we need to get involved. Second, I think there's a question for the community, which we'll worry about in a couple of years' time probably, which is that launching Rubin Citizen Science Project is going to be bunchy, I think. My guess is the month after a data release is going to be really busy. And I think we need to think about whether we try and coordinate so that doesn't happen, so we spread things out, or maybe we just make a virtue of it and we have the month of Rubin Citizen Science and we try and put all our projects in that one basket. I think that's a problem for success and a problem for the future, but that's something that needs thinking about, I think.
Okay. Chris, since you have the microphone, this is a perfect for you to start answering the second question, and that's to do with publications. If we do succeed in getting many projects in the Rubin family, and we have a lot of citizen science, you could imagine a circumstance where you wind up with many, many interesting things and that are not huge, something that might not merit an AppJ paper or something like that. This happens with undergraduate research all the time, right? And so we find venues like, for example, the excellent research notices of the American Astronomical Society or AAS abstracts or things like that. If we wind up getting a flood of people who want to publish little things, should we just use those mechanisms that already exist, like our NAAS or something like that? Or do you envision maybe creating something within Rubin, some sort of Rubin, amateur science journal or citizen science journal where people can just sort of put, hey, check out what we found, kind of making everyone feel like there's that end point as well, not just contributing to the science, but actually being able to get a result somewhere in the literature or some sort of dissemination.
Yeah, I think it's really important it's external to the project, actually, because it's important that these things live in the broader ecosystem. I think that's what people value, and it shows the worth. As you know, I suspect that others in the room might not. I'm the editor of the research notes of the AAS, as well as an AppJ and AJ editor, and I'm happy to talk to anyone this week about publication stuff. But research notes, which are 2 pages, 1 figure, moderated rather than peer reviewed. One of the reasons we invented it was to lower the bar for undergraduates doing REU experiences or citizen scientists to be able to publish their own work rather than needing to collaborate with somebody to create a whole paper. So we're already seeing, I showed in my talk, the first citizen science Rubin notes where people say, look, found a thing, it's here, it has these properties. This might be interesting. And because although it's not a peer review publication, research notes are indexed in ADS and can, if they meet archives criteria, go on archive as well. So I think that's the right venue. And we're, from a AAS point of view, we're happy to support that.
Yeah. And I would just add, I think one of the things that I'm excited about doing is on the resources we have, like the website and stuff, is creating places where we can really highlight all of these papers and everything that citizen scientists do together, so they don't get lost in the noise, and we can have a place where we can, you know, point people to and say, look at all this amazing stuff that everyone has done together. And so putting that all together in one place.
Okay. Just to wrap, and then please continue. So you're saying that we should publish externally and then tell you so that you can put it in the cool Rubin highlight thing.
Yes,
that's
exactly.
the way you should. Okay.
And I will say we are 2 minutes over time. So I just wanted to say a big thank you to everybody here and for the great discussion, and happy to continue the discussion. But I know it's been a long day already, but thank you very much, everyone.
Thank you.